Hello everyone. In today's video, I'm going to discuss about the solution of Leetcode problem 179, which is largest number. So in this video, I'm going to solve this problem using topological ordering of the graph. So let's read the problem first. Given a list of non-negative integers numbers, arrange them so that they from the largest number and return it. Okay. So let's see the first input, which is 10 to. So we can rearrange these two numbers in two ways. One is 102 and another is 210. So among these two, 210 is the largest, so the output is 210. So how to solve this problem? So you can solve this problem simply custom sort function of any language and pass the test cases easily. But in this video, I'm going to show you how to solve this problem using topological ordering of a graph. So here, let's consider the second test case, which is 3, 3, 0, 3, 4, 5, and 9. So here, how many pairs are possible of these 5 numbers? That is 5 into 4 by 2. So we will consider every pair here. So, and we'll check for every pair which one is bigger. Let's suppose we are comparing among these two pair. So 3, 3, 0. So among 3, 3, 0, there are two possible combinations. One is 3, 3, 0 and another is 3, 0, 3. So we can see from here that 3, 3, 0 is bigger than 3, 0, 3. So we will add an out edge from 3 to 3, 0. Again, we'll compare 3 and 3, 4, and as you can see, among the two comparison, 3, 4, 3 is greater. So we will add an edge from 3, 4 to 3. So we'll consider these 5 numbers as a node of a graph. So these are like 5 nodes of our graph, and we'll compare among every pair. Okay, so among now if you compare 3, 5, so 5, 3 is bigger, so we will add an edge from 5 to 3, and this is a directed graph. Okay, so for again 3, 9, 9, 3 is bigger, so we will consider an edge which is from 9 to 3. Again for 3, 0 to 3, 4, we can see 3, 4, 3, 0 is greater than 3, 0, 3, 4. So we'll add an edge from here. Okay. So again, for 3, 0 to 5, um, we can see 5, 3, 0 is greater. So we will add an edge. Okay. Again, for 3, 4, okay, 3, 0, 5, 9, 3, 0 is bigger. So we will add an edge from 9 to 3, 0. That's how we will complete our graph by adding directed edge. Now, the topological ordering which will be formed from this graph is the answer of the problem. Okay, so now we will find out the topological ordering for the graph, and we'll see and return the topological ordering. So how to implement this problem? So let's consider another example of 3 nodes. Okay, and let's consider 53. Okay, so Now let's consider an edge like 539 is greater than 953. So there is an edge from 9 to 53. Again, there would be an edge for 9 to 53. And if we compare these two pairs now, like, okay, so as you can see, there is no one between 9 to 9. Now, if you compare these two nodes, there is no one which is like greater. Okay, so there shouldn't be any edge from 9 to 9. Okay, so now let's find the topological ordering of this graph. So as you can see, the degree of 9 is 0, and degree of 9 is 0, and the degree of 53 is 2. So we'll push like find the topological ordering from the degree. So we will consider the 0 degree first. So let's pick this node 9 and cut this. So the degree would be 1 now. Again, let's pick 9 and the degree will be 0 now. Again, the new degree of 53 is 0. So again, we'll pick 53. And how to find topological ordering of a graph? Just pick some degree which are 0 and continue the process. Okay, so let's implement this problem. So they have provided a vector of nums. So what I need to do first, uh, I have to create an adjacency list. Okay, so let's declare the size, which is n, is the equivalent to nums dot size. Okay, so for the I equals 0, I less than n, I plus plus, for j plus n, j plus plus. Okay, so string a equals to string nums I, string b equal to string nums j. So if a plus b greater than b plus a, so what I will be doing, I would add an edge from I to j. Okay, so yeah, so let's declare an adjacency list, vector integer edge n, which is my vector integer inside 2. Okay, so yeah, so what I will be doing now, um so there should be an edge from I to j. Else if there should be another condition, if b plus a greater than a plus b, then what I'll be doing, I would push another edge, uh, which is j to I. And let's, okay, so to find topological ordering, I need another array which will store the degree. Okay, so degree of n. Fine, so yeah, so if I add an edge from I to j, so degree of j would be increased by 1. And here I'm adding an edge to I, so degree of I would be 1. So now we have to find out the topological ordering of the graph. So we would be needing an queue. So let's first insert in the queue which all that node. So let's first insert in the queue that nodes which degrees are equal 0. So let's iterate over the nodes. So if degree of I equal to 0, then I would push the i's into the queue. So now let's find out the topological ordering. So while not queue.empty u is equal, so let's pick the top element of the queue. So front element of the queue. So queue.front. Okay, and we need to pop queue.pop. So for auto v to add u. So my degree, every time my degree would be decreasing by 1. So if degree of v equals 0, then what I'll be doing, I would be pushing the new node v on the queue. Push v. And okay, so we're done with the topological ordering. And also there is another task left. I need to return the answer string. So let's declare an string which is empty initially. And every time I will be doing ans plus equal, I need to add my nums which are on the top with the answer. So let's concatenate this. So to string nums u. So let's return it. So let's run this program on the test cases. So as you can see, it has passed the test cases. So let's submit this program. Oh yeah, so I need to check the condition for 0 as well. So let's see the answer which I have returned, like all the positions are 0 or not. So how to check it? Okay, fine. So I need to check if ans.back equals 0 and ans 0 which is uh, equals to 0, then what I will be returning, I will be returning an string which will contain only a single 0. So let's um, submit this solution. So as you can see, the problem is accepted. Okay, so thank you everyone for watching this video.